Greetings! Checking out the lighting a bit. Okay. I guess Bridge Brewing Company. Anyways, we have the Grinch today. We're gonna explain to you, we're gonna build you a model of how the sun moves in the south. Oh my gosh, look at this thing, it's brown. I don't know. Could be the best. Not bad. Okay. Okay, so we worked it out. Oh my gosh. Okay. So there's the Earth right there. And this guy's looking north, obviously, that's north. And this is his right and left. Okay, right to left. So he's looking north. And we were saying around noon, you look north to see the sun. Okay? And that's what he's seeing right there. Okay? You can see that, right? Move this out of the way. So that's perfect. Because that's east is obviously to his right. And you see the sun coming in. And you could even see how lovely it's coming up from bottom, well actually yeah, from right to left. Yeah, what am I saying? From right to left. That's what it looks like it's doing, right to left. Of course it's more up above, but he can only see, he can't see that whole semicircle, this yellow here. He can see like a few hours around noon. So like from there, you know, to there, let's say, something like that. Okay, the maximum he could see would be the whole thing if he turned around to go noon. But that means he can't see the sunrise and the sunset. We already know those are in the south. So here's the sun from the top view. Okay, it's circling in front of him, and he sees the yellow part. Okay, that's northeast, and that's northwest. Okay, you can see the angle is correct. At high noon, it's above his head. And so it's going, you know, from bottom right to upper left. That's what you expect the sunrise in the northeast to do. And then the sunset is going, obviously, from upper right to bottom left. So it's always right to left. This is all going right to left. And he's looking north. He's in the far south. He's south of Capricorn. Sun's going, oh, sorry, it's going this way, counterclockwise around Capricorn. Now he's going to turn around. So you notice that's the converging. When he looks north, the light is in front of him. It converges. Okay? You see this part there? It's going up. Converges. Say stand up, man. Converges at noon. Okay? And then it just goes right back down. Okay, it goes back down on that side. So, in the morning though, so in keeping with this direction, okay, when he turns around to look south, he sees this part. He sees the refracted northern part of the sun's loop. He's going to see this, and the sun is going to keep going this way. So this part here, from there to there, is going to be his sunset. Okay? This is, and then this part here is going to be his sunrise. And you see, we preserve the circle of the sun, going in the same direction. So let's just swing that over to him, and he won't ever see this point here. That's where okay, he won't see that. That's okay. So it's impossible to see the midnight sun. You'll never see that. You see the paths are diverging. Okay, let's just fold this up just to show you what he's seeing. You see it right there, the diverging paths. So that's his sunrise over here. It's going obviously from bottom right to upper left. And the sunset's going from upper right to bottom left. It's always right to left. Let's just turn it around from his point of view. Okay, and that's what he sees right there. There's the sunrise, bottom right to upper left, and there's the sunset, upper right to bottom left. It's all right to left, and he'll never see this part here, right there. That part is always hidden. You can't see it, because why? It's diverging. What does the diverging mean? It means the light's behind you, obviously. Okay, so that's what he's seeing. He's seeing this part here. That's his sunset, and that's his sunrise. It makes perfect sense. This is what he's seeing around noon when he turns around. Okay, so let's put some numbers to that just so you can see the direction more clear. When he's looking south, these are the numbers he sees right there. Okay, it's coming in 1, 2, 3. He'll never see 4, and then 5, 6, 7 is the sunrise. So that's the counterclockwise rotation. So we can put that behind him now. You can see it totally preserves the same rotation. He's looking north now. You see there's his northeast sunrise going up. That connects to this path here, okay, the counterclockwise. So this path now meets in front of him. It converges. You see how it converges? It's going from bottom right to upper left, and then it goes from upper right to bottom left. Okay? They converge right here. Sorry. Right there. Okay, that's high noon. Okay? High noon, and then you see the numbers. It's going counterclockwise, 1, 2, 3, because he's looking north. Okay, that's the path. And then it gets refracted. So when he's looking south, there it is. The same path. It just got refracted. So 1, 2, 3. You see? And then 5, 6, 7. Okay, and then when he's looking at it from his point of view, okay, let's turn it around. Okay, and there you have it. Okay, what's he seeing? What's his sunrise? Okay, bottom. Okay, sunrise is bottom right to upper left. Okay, let's just put it way out here a bit so you can see it better. Okay, his right hand to the right of your screen. His left hand, look at it going up. 5, 6, 7. Okay, bottom right to upper left. The sunset's coming in. 1, 2, 3. Upper right to bottom left. Okay? It doesn't get clearer than this. Okay? You can't beat that. This is as perfect an explanation as you're going to find. Okay? Then when he turns around to see north, everything is preserved. Everything. You turn him around. Okay, he's looking north now. There's high noon for him. Okay, you see that's high noon right there. And then the sun continues on its counterclockwise circuit according to him. Okay, 1, 2, 3. You can't see 4, 5, 6, 7. So that's converging paths. Okay, he's facing the light source. That's why he has to look north around noon, because the sun is still at Capricorn. It can't go past Capricorn. So what you're seeing again in the far south, when he's looking south to see the sunrise and the sunsets, it's right there. Okay, right there. Okay, he's seeing the refracted, this refracted northern half of the loop. Okay, that's right there. When he looks south, this is what he sees. Okay, this part. And it works perfect. You see that right there. Okay, this is going to be his sunset, upper right to bottom left. This will be his sunrise, bottom right to upper left. Okay, come on, it's not hard. It's super easy. So yeah, I think we covered it. And that's the only way you can explain the diverging paths in front of him. Okay? To the right is the sunset, boom. To the left is the sunrise. Okay? 5, 6, 7. And it just keeps going in a circle. All right? That explains the observations perfectly. Okay? Where these numbers are, that's the northern half of the sun's route right there. Okay, you see it? It's still going. 1, 2, 3. It never changes. Okay? But this is so far away from him. Somehow it gets refracted. We know the dome is shiny like a mirror. And there it is. It's just the same ring. Except the bottom, that northern half gets refracted. That's why the diverging. And so you see the sunset is going from right to left. This is exactly what you would expect to see for a sunset if you were looking northeast, or northwest, but he's looking southwest. And the same with the sunrise. This is exactly the sunrise you would expect to see in the northeast, but you're seeing it southwest. Okay? It just couldn't be clearer than that. And again, just try it out. Turn it around. Turn him north. Okay, turn him north. He's facing north now. And there it is. Okay, there it is. Everything is preserved. Okay, you see? That's the northwest right there, sunset, going down. Okay, that's the path. And there's the sunrise, bottom right to upper left. It's right there. So you're seeing this refracted northern part of the sun, because this is already high noon here, right? So half the day is already gone. This will be the first half of the day for him, for sure, reflected right there. And he just turns around. He's looking south, and there it is. Okay? It can't be explained more perfect than that. That's all. I'd love to see anybody try to do it. Okay? And I didn't do this properly. Look at this. That's the Lionsgate Bridge that goes from Stanley Park to North Vancouver. See, bridge. An amazing engineering thing they did on that bridge where they widened it. I think it was the first time ever in the world that that was attempted for that kind of a suspension bridge. Yeah. So there it is. We killed it. We killed it. There is no mistaking what's going on. Okay? No mistaking at all. Okay, check this out. We're in Antarctica, and I shouldn't even have to say that, but we are. You should be able to know right away what's going on here. So you see the sun coming from, it's going right to left. That's northeast sunrise you're seeing right there. It's going to converge in front of you. and then it's going to go right to left again, and it's going to set in the northwest. So what you're seeing here is the southern part of the sun circuit. The sun is the furthest away it can be, which is in the Tropic of Cancer, and it's just starting to move down towards the Tropic of Capricorn. Okay, so this is a perfect example of looking north around noon to see the sun. You see it converge in front of you, one continuous path right down to sunset. You cannot deny this, okay? Simple as that. And so this is going on. This was filmed 21st of July 2019. So as this thing goes down to Capricorn, the sunset will go from the northeast and northwest. You'll start seeing it in the southeast and the southwest. At the worst time of the year, if you're trying to fake 24-hour Antarctica sun, that's exactly the same time of year when you're supposed to be seeing the best southwest and southeast sunrises and sunsets of a counterclockwise moving sun in Antarctica while looking south.
What the freak is this?
Okay, so we need to talk a little bit about this diagram. This is what's been going around from Team Globe. This is what they used to trick Jake. It's really, we've uncovered a triangle here. It was Eric Dubé's supposedly ex-girlfriend that showed this to Jake. Oh, I broke up with Eric, blah blah. And then she's showing him some webcam of a hotel, and she's trying to say, oh yeah, see, it's the southwest sunset, the southeast sunrise. Yeah, but the sun's not going clockwise, and that was the trick, and that's how he got fooled. The sun's actually going counterclockwise. They shouldn't be joined. It should be two separate paths. So anyways, the red is the circling sun around Capricorn. This is the worst time of the year to be trying to film the 24-hour sun, because it's the best time of the year for the southeast and the southwest sunrises and sunsets all the way down to Antarctica. And so you're going to see the reference video coming up soon from Australia, 32 degrees from the east coast of Australia, and that'll just reinforce everything we just said about what's going on at that time of the year. That one was filmed January 12th, 2019. It just so happens. What a coincidence.
You can put this nonsense to bed with just a stick in the ground. When the sun is circling above the Tropic of Capricorn, shadows rotate in opposite direction, on either side of the tropic.
Sunrise and sunset angles absolutely prove that the sun does not go in a circle around an AE map.
Okay, here it is again. Look at this. Look at the beauty here. Okay, it's the circle, preserves everything, the counterclockwise, everything. And so he won't be able to see himself. Obviously, he's just going to see this. That's the sunset. 1, 2, 3. Hang on. And there's the sunrise. 5, 6, 7. Okay, so it works perfect. No question about it. Okay, and that's the end of the globe. That's it. They can't have a counterclockwise moving sun in the south at the same time of the year that they're claiming they're filming a 24-hour sun looking the opposite direction north. It doesn't work, and that's why there's no historical record of the 24-hour Antarctic sun. Okay? That's it. And that's the end of the globe. Ha ha ha.
Okay, look at the situation on the map there. Okay, that's a huge problem. I mean, look at the layout of the land. So you're getting southwest sunsets, counterclockwise moving sun, while looking south, all the way as far south as you can go, let's say 77 degrees. At the time of the year, December, January, where they're supposedly looking north at a 24-hour sun. Yeah, right. Okay, we're looking south at that time of year at the counterclockwise sun, the southwest sunsets and the southeast sunrises. So we're going to move all the way to 77 degrees now, and we're going to see what Captain Ross had to say while he was looking at the volcano that was south of him. The sun was setting west of him. So let's just read the story a little bit here. Okay, so Captain Ross, an early explorer, made 3 trips to Antarctica, and not once did he mention a sun visible for 24 hours or a midnight sun. Okay, so Captain James Clark Ross took command of the 370-ton Erebus, with his friend Francis Crozier assuming command of the 340-ton Terror. Antarctica was the new challenge. Okay, so Antarctica was the new challenge. So let's keep reading here. So, okay. On October 5th, 1839, the Erebus and Terror left England on their southern voyage. On New Year's Day, 1841, they crossed the Antarctic Circle. Okay. On January 28th, there was another surprise. Beaufort Island, first charted by Ross in 1841, 77 degrees south latitude, 21 kilometers north of Ross Island. So they landed at that Beaufort Island, and they're looking south 21 kilometers at the volcano, which they named it Ross Island, where the volcano was. And Mount Erebus, the name given to the active volcano on Ross Island. So that's 21 kilometers ahead of them. Robert McCormick, Erebus's surgeon, described the discovery as a stupendous volcanic mountain in a high state of activity. Okay. Dr. Hooker ran to get his notebook and quickly wrote down his reaction. Okay, this is good. All the coast, one mass of dazzling, beautiful peaks of snow, which when the sun approached the horizon reflected the most brilliant tints of golden, yellow, and scarlet. And then to see the dark cloud of smoke tinged with flame rising from the volcano in a perfectly unbroken column. One side jet black, the other giving back the colors of the sun. This was a sight so surpassing everything that can be imagined that it really caused a feeling of awe to steal over us at the consideration of our own comparative insignificance and helplessness, and at the same time an indescribable feeling of the greatness of the Creator in the works of His hand. So that peak was 12,400 feet above sea level and was belching flame and smoke. Ross named it Mount Erebus, and the smaller extinct volcano to the east, Mount Terror. So let's just talk about that for a second. The sun was lighting up one side, half the column of smoke, which was in front of him. Dr. Hooker was looking south while the sun was setting. Therefore, light was coming from the west, obviously. From the west side, the sun was setting. The dark side of the column was to the observer's left, which is east. The lighted side was to the right, west of the observer. So, Dr. Hooker ran to get his notebook and quickly wrote down his reaction. Why was Dr. Hooker in such a hurry? Because the sun was setting fast. Okay? So, it makes perfect sense because in Antarctica is the coldest place on Earth, and that's because the sun never goes further south than Capricorn. Literally past 60 degrees, there's hardly any life compared to the north, where there's all kinds of life, like even past 80. There's seasons there, there's food to hunt, deers, and all kinds of things. Bears. So, it's not a mirror image at all. It's a cold, hellish place, as described by the explorers. Not at all like the north. And think, it's the highest elevation of any land on Earth. Okay? And you saw how tall that volcano was. So, that makes perfect sense for containing the water. Okay? It's not some big chunk stuck on the bottom of a ball. Like, that doesn't make any sense. So, everything makes perfect sense, and that's why, like, even in Australia, when the sun's going around Capricorn, that's its biggest circuit, it's going faster. So twilight is shorter and colder. Nights are cooler there. Okay, compared to the north, man, we have like endless summer nights. Okay, literally, and it's warmer, it's way different. So reality supports reality. Okay, can only be explained by reality. Our observations in the south can only be explained by a circling sun over a Gleason map and a reflective dome. Period. There is no other explanation, and that's the end of the globe. Okay, here we go. This is going to be 12th of January 2019. This is the reference sunset. Here's the sunrise. He's already showing you it's in the southeast. It's amazing he didn't notice that it's going from bottom right to upper left. Just incredible. And at this time of the year, is supposedly when they're going to be filming the 24-hour Antarctic sun, the time of the year where these sunsets are at their max, like the southeast and the southwest sunrises and sunsets in the far south, which is everything south of Capricorn. So there he is now, he's looking north, midday. You can see the time, it's not even 12:30. And look at that beautiful shadow of a clockwise moving sun. Counterclockwise, sorry. Because he's looking north. And there it is, up the pole. And you see it's north of that post. It's north because it's at Capricorn. And he's at 32 degrees. But look how close it looks. Okay? There's the sunset. Right through the clouds. That's incredible. There it is. Upper right to lower left. Okay, there's no way they filmed a 24-hour Antarctic sun with this going on. Okay, period. It's a lie. Straight up a lie. That's right, you can only see this with the circling sun. We've already proven that. We've got more examples to come as well. Yeah, like it says, it proves every video that claims the 24-hour Antarctic sun is fake. Yeah, how are you going to be looking north all day? How's the sun going to be in front of you, okay, circling around you? No, it's circling behind you. That's why it's called the Antarctic. It arcs behind you. Oh.
You can stick around for more destruction of no map, no model, no circling sun stupidity.
Cape Palliser, New Zealand. Same thing. Okay, you're looking at a real 24-hour sun in the north, the Arctic midnight sun. Notice how when it peaks at the maximum height, that's 12 noon. It's closest to you. You're offset from the North Pole. And then it slowly makes its way back down to midnight, which is the lowest point. And then it rises back up again. Look at the beautiful color gradient that follow the sun. Okay, that shows it's a small local sun moving. Look how smooth the 360 is. It's seamless all the way around. We're going around a few times in this one. Okay. Right there, noon. The paths are converging right in front of you. You're looking at the sun. The light source is in front of you the whole entire time. Totally not possible in Antarctica. Period. It's just not possible. At the time of the year when you're supposed to be watching supposedly their 24-hour sun, just happens to be the same time of the year, you know, which is the northern winter. Let's say December, January, where these southeast sunrises and southwest sunsets south of Capricorn have the diverging paths of a clockwise, counterclockwise moving sun while you're looking south in the far south, okay? Which means the sun is behind you while you're looking south. That's why when you look north, you see that the paths converge. And that's the end of the globe.
Les photos sont ensuite empilées dans des calques Photoshop. Voici ce que donne chaque image du soleil. Et maintenant, l'assemblage de ces photos. Photoshop peut arranger toutes les photos du soleil grâce au mode de fusion éclaircir, sauf pour le premier calque qui est en mode superposition. En gros, et voilà,
That's
c'est
the end of the
miraculeux.
globe.
Merci de votre attention.
We finished the bridge. I don't want to finish this all right now. Let's get this out there. Okay, this is the only thing we need to be talking about, really. Just we need to know this is a new thing. Okay, it's a new thing based on new evidence, and the new evidence, of course, is that just incredible video of the Australian sunset. Yeah, that globe head produced the best flat earth proof to date that shuts so many people down, you know, these no model people, these no map people, these no circling sun people. You're all done. Every one of you